Okay, 7.7. It just occurred to me as I'm seeing myself on my own computer that I have been wearing this Davenport 23 shirt for a while. 23 is my favorite number. Do you know why? What are some reasons why 23 would be? Some people know right away is Michael Jordan's jersey number, and he's, I guess, a hero of mine among many others. So that would be maybe one reason, but there's other reasons. Another thing is 23 is a very big part of me. It's also a very big part of you. All of our chromosomes are matched in pairs of 23 chromosomes, 23 pairs. Okay. So that's another one. But I especially like it because it's a special number. I think it's the most royal of any of the numbers. Okay. What am I writing down here? These are all the prime numbers, okay? These are all the numbers that can only be divided evenly by themselves and by 1, okay? 2, 3, 5, 7, 11, 13, 15, of course, is 3 times 5, so that's no good. 17, 19, 21 is 3 times 7, 23, then you have 25, which is 5 times 5, 27, which is 3 times 9, then you have 29, 31, you have 33, 35, 37, and so on, okay? So those are all the prime numbers. We'll learn later on in the course how many of them there are. But anyway, 23 I think is the most, all these are very special, okay? So they're kind of the noble, they're the nobility of numbers. And 23 I think is especially noble, because all these other ones are close to another prime number. 2 and 3 are only 1 apart. These are only 2 apart. Those are only 2 apart. These are only 2 apart. Those are only 2 apart. These are only 2 apart. 37, I guess then, I guess there's another one. But this is the first prime number, which isn't just right next to, just 2 away from some other prime number. So it's especially special, okay? So anyway, that's why I like 23. Okay, do you have a favorite number? Anyway, here is the quadratic equation. And again, this is a very important equation. This is a very important expression. Those show up a lot. We're going to be spending a whole chapter working with things like this. And so we want to know, when will this thing be equal to 0? Okay, you just have to trust me at this point that this is an important question to answer. And so we want to answer it, and then we'll apply it as we go through the course. So first of all, let's look at some special cases, okay? First special case is if you let a be equal to 0. If a is 0, then you just get bx plus c is equal to 0. So for example, you could have 5x plus 7 is equal to 0. And that's easy enough to solve. Agreed? You bring the 7 over, you're going to get 5x is equal to negative 7. And then you divide both sides by 5, and you get x is equal to negative 7/5. Okay, so if a is equal to 0, and these are a couple other numbers, then it's easy to solve. If b is equal to 0, then it's also not bad. Let's take an example. Let's say you have 3x squared plus 27 is equal to 0. Okay, let's try it and see what happens. So we're going to get 3x squared is equal to negative 27. Agreed? If you divide both sides by, if you subtract 27 from both sides, you get this. Now we'll divide both sides by 3, and we'll get x squared is equal to what? Negative 27 divided by 3 is negative 9, right? And now you want, what's the value of x that when you square it, you get negative 9? Holy smokes, you want a number that when you multiply it by itself, you get a negative number. Well, that's not even possible. Not if you're working in the world of real numbers, it's not even possible. So this one right here doesn't even have a solution. If you look at it right away from the beginning, you see that x squared is always going to be 0 or positive, and by the time you add 27 to it, there's no way you can make this thing 0. Okay, the smallest this will ever be is going to be 27. So some might not even have a solution, but let's change it just slightly and see once what happens if we have that one instead. Then we get what? Then we're going to get 3x squared is equal to positive 27. And so x squared is equal to 27 over 3 is what? 9. And now x is, what's the number that when you multiply it by itself you get 9? 3 is one answer, but notice that negative 3 is another answer. So you get two possible answers there when you have x squared is equal to 9. Finally, let's take c is equal to 0 as a special case. And let's, I don't care, let's just choose either one of these. Or we can choose another one. C is equal to 0, let's just say 5x squared plus 15x is equal to 0. Okay? What happens there? Well, let's see. Here's the way to do this one. The way to do this is to factor as much out from both of these as you can. And the most important thing you can factor out is an x. I can factor out an x. In this case, I made it kind of simple, so I can also factor out a 5. And so I have a 5x. And what am I left with? I'm left with an x here, and I'm left with a 3 right there. Okay, see that? You factor a 5x out. If I were to multiply this back in, I'd get 5x times x is 5x squared. 5x times 3 is 15x. So this is the same as this. And now, here's the key. This thing is equal to 0. Here, I always tell my class, 0 is your friend. Why is 0 your friend? Let's think about this just a second. If I have a times b is equal to, I don't care, let's say it's equal to 3. What are all the choices you could have for what a and b are? Holy smokes. You could have 3 and 1. You could have negative 3 and negative 1. You could have 3 over 5 and 5 over 1. You could have 3 over 17 and 17 over 1. You could have, I mean, the point is there's just lots, billions and billions of examples. You could have negative 3 over 17 and 17 over 1, a negative 17 over 1. Billions and billions of things that are all different from each other that all end up multiplying to 3. Okay, so 3 isn't your friend. Okay, it's not your enemy, it's just not your friend. But as soon as you put a 0 there, and you say the product of two things is 0, now you know something for sure. What do you know for sure? If the product of two things is 0, with 3 you could have had this, or you could have had 6 and 1/2. These things could have been anything. They could have been anything. But as soon as you have the product of two things is 0, you know that one of them has to be 0. That's the only way the product will be 0. And so this implies that either a is 0 or b is 0. And so that's going to become very important as we go through the course. If a times b is 0, one of those two things has to be 0. That's key. That's why whenever you want to solve for x, you almost always, I think I can probably say always, set it equal to 0. Okay? Put everything on one side and set it equal to 0, and then you can make use of the fact that 0 is your friend. Okay, I'm going to leave that up there. So now you have the product of two things is 0, so one of two things has to be true. Either 5x has got to be 0, or x plus 3 has got to be 0. Either one of them will make this thing 0. If 5x is 0, you can divide both sides by 5. I guess I will get rid of this now. You can divide both sides by 5 and get x is equal to 0. If this is equal to 0, you can subtract 3 from both sides and get x is equal to negative 3. So those are the two possible solutions to this equation, both of which make this true. In fact, let's check it out. If x is 0, sure enough, that's going to be 0. If x is negative 3, I'm going to get negative 3. Negative 3 squared Negative 3 squared is what? Is 9. 9 times 5 is 45. Negative 3 times 15 is negative 45, so sure enough, it gives you 0. Okay? So anyway, those are 3 special cases. Okay, I'm going to get rid of them now. Now, we've also got special cases like this. What if you have a special case like x squared plus 7x plus 10 is equal to 0? I call that special because we know how to solve this one already. We can factor that, right? Did you see it when I put it up there? It's going to be x plus 5 times x plus 2 is equal to, is equal to 0. Because notice, if you multiply this out, you're going to get x squared plus 7x plus 10. So this factors into this. And now you can use the fact that 0 is your friend again. And so you either get that this thing is 0, or you get that this thing is 0, which means that x is equal to negative 5, or x is equal to negative 2. So you got those two solutions. So another special case is when you can factor it. If you can factor it, you normally should, because that's the quickest, easiest way to do it. Okay? But there might be times, and in fact there quite often are times, when you have something like this. 5x squared plus, I don't know, 8x minus 7 is equal to 0. Okay? And there's no way you're going to be able to find a way to factor that. So we need a general formula that tells us exactly what the solution to that thing is. Okay? So here is the formula. We're going to go ahead and get it. Let me write this up here, just so I have a little more room downstairs there. And let's go ahead and find the solution to this thing. Okay, here's what you do. Every one of these steps you should understand. You might not understand why I'm doing it. You'll see it at the end why I'm doing it, but at least you should agree that I can do it. So the first thing I'm going to do is I'm going to bring the c over to this side. So I'm going to get ax squared plus bx is equal to negative c. You agree I can do that? I can subtract c from both sides. Now I'm going to factor an a out of these two things. Watch. I'm going to get x squared plus b over a times x is equal to negative c. Now as soon as I do that, you should have two things that go through your mind. One is, why in the world would he do that? And the second is, yeah, I guess he can if he wants to, right? Because notice, if I multiply this through, I'm going to get ax squared here. If I multiply this by this, I have to distribute it. The a's are going to cancel, and I'm going to end up with a bx. So you don't know why I wanted to do it, but you have to agree that I can. Okay, I can. Okay, now I'm going to do something even weirder. Okay? I added and subtracted the same thing. Do you agree I can do that? If I add and subtract the same thing, I've just added 0, and you can add 0 to anything without changing it. And again, you should be asking, why in the world would you want to do that? You'll see why in a minute. Okay? Here's the next step. I'm going to take this one and I'm going to bring it outside the parentheses. And anything I bring outside the parentheses, I have to multiply it by a. So watch carefully. It's going to be a times now, when I bring it out, I'm going to multiply it by a, so it's going to be negative b squared over 4a. It's equal to that. Okay? Now, I'm going to show you why I did all this. Okay? I'm going to do that in the next step, just because I can tell even though this is on a video and you're watching it, I can tell you're really wondering, why in the world did he do this? Here's why I did it. Because this thing I can now write as x plus b over 2a quantity squared. Is that right? Let's check it out. Let's go over here and check it out. If I have x plus b over 2a squared, that means I'm multiplying it by itself. Agreed? Means I'm multiplying it by itself. And now if I multiply this out, I'm going to get x times x is x squared. Then I'm going to get a bx over 2a. That's my inner. Here I also get a bx over 2a. And then finally, this times this is going to be b squared. And the bottom, I square the bottom, it's going to be 2 times 2 is 4. A times a is a squared. And notice that here I can factor a bx, well, I mean, I can think of this as, oops. Okay, I can bring the 1/2 out front, and I have half of one of these things and half of one of these things. And if I have 2 halves, that gives me a whole. So by the time I add those 2 halves together, I just get the whole thing, which is bx over a, right? A half of something plus a half of something gives me the whole thing, plus b squared over 4a squared. Is that what I had right here? Sure enough, look, x squared, b times x over a, b times x over a, doesn't matter whether the x is there or up there, and then b squared over 4a squared. Are you with me? So I could do it. I could do it. That was legit. And that was the reason why I did all these other things, and now you're going to see why this all works. Okay, here's the next step. I'm going to bring this over to the other side. I'm going to get x plus b over 2a quantity squared. If I bring this to the other side, it's going to be b squared over 4a minus c. Okay, are you staying with me? So I add this to both sides. Now I'm going to get a common denominator here. Okay, so I'm going to get a times is equal to, well, what's a common denominator? This is just c over 1. So if I wanted a common denominator, I'd have to multiply both the top and the bottom by 4a. Do you agree? If I multiply both the top and the bottom by 4a, I've just multiplied that by 1, so I can do that. And now I have a common denominator, so I can write this as b squared minus 4ac all over 4a. Okay? Now I'll divide both sides by a. We're almost done. This is kind of cool. I remember learning this when I was in algebra, and if I divide both sides by a, we're going to get this. And now we'll take the square root of both sides, okay? Now we'll take the square root of both sides. So on this side, I'm just going to get x plus b over 2a. And on this side, when I take the square root, that gives me the square root of the top divided by the square root of the bottom. But the square root of the bottom is going to be the square root of 4, which is 2, and the square root of a squared, which is a. And whenever you take the square root, just like we had as x squared is equal to 9, we had x is equal to plus or minus 3. This is going to be plus or minus each of these. So you have that. And finally, we have x is equal to, I can bring this over, and it's going to be negative b over 2a plus this whole thing, I should say plus or minus. And now notice I have a common denominator, So I can write it all as one big thing, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Look at that. So I just lost my video. I want to just make sure that you're still with me. Very good, you are. Okay, so it turns out, now that we've got the proof, I'll get rid of all the derivation of it, and let's write down the answer. X, the x which makes this statement true, is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And of course, a is the thing in front of the x squared, b is the thing in front of the x, and c is the other thing. So let's go ahead and use that to get the solutions to this quadratic equation right here. Quadratic means a quad is something which is has 4 sides, and if it has 4 sides, it's a square, and you have an x squared there. So that's why you call that a quadratic. Okay? So what are the solutions? What does this say? It says you take negative b, so it's going to be negative 8, plus or minus the square root of b squared, 8 squared is 64, minus 4 times 5 times negative 7, all divided by 2 times 5 is 10, all divided by 10. So that's going to be negative 8 plus or minus the square root of, well, notice I have 2 negatives here, so I can cancel the negatives. And this is going to be 64, and this is 20 times 7 is 140 all over 10. So that's going to be negative 8 plus or minus the square root of 204 all divided by 10. Okay, there's the answer. Now we can make the answer a little bit better than that using some of the things we already know. I didn't give myself much room, but I can factor. Here, let me do this. Negative 8 plus or minus, let's do this over here, 204. If I divide that by 2, I'm going to get 102. If I divide that by 2, I'm going to get 51. Agreed? So that's equal to the square root of 4 times 51 all over 10. Now, I can make use of this property. This is where these properties are so important. The square root of a times b is the square root of a times the square root of b. So this is negative 8 plus or minus the square root of 4 times the square root of 51 all over 10. Of course, the square root of 4 is just 2. So let me just go ahead and make that a 2 right now. And then you can factor a 2 out of everything, and I'm going to get 2 times the quantity, negative 4 plus or minus the square root of 51 all over 10. And now I can cancel that 2 with a 10 and get a 5 right there. So the final answer is x is equal to negative 4 plus or minus the square root of 51 all divided by 5. No way we would have gotten that without the quadratic equation. Okay? So that's the idea right there. Pretty cool. Okay, and you can practice those in class. Lots of different ways to practice them. By the way, just a couple things I should mention is if you have, let's just take a simple one, x squared plus x plus 1. Let's just take a very simple one and get that one. And so if you use, I should have, doggone it, why did I get rid of that? Ax squared plus bx plus c is equal to 0. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So all these things are 1s. And so what does x equal? X equals negative b plus or minus the square root of 1 squared minus 4 times 1 times c is 1 all over 2 times 1. So that's negative 1 plus or minus the square root of 1 minus 4 is negative 3 all over 2. See that? Whoa, what's this telling you? There is no number. There is no number that when you multiply it by itself gives you -3. There's no real number that when you multiply it by itself gives you -3. So if I have a -3 inside the radical like that, that tells me that there is no solution to this, okay? Or no solution. No solution. I should make that a point. Okay? Very good. Let's do one more. This just shows how these things are useful. Here's an applied problem for you. If you throw something up from the top of a tower, which is 48 feet high, and you throw it up at 32 feet per second, okay, you toss it up, then here's the ground right here, then the height of that object above the ground is given by -16t squared plus 32t plus 48. Okay? Anyway, that gives you the height of this thing above the ground at any point. And what if you're interested in when will it hit the ground? When will it hit the ground? So it's going up this fast. It starts 48 feet high, and you want to know it's going to go up and come and hit the ground. When will it? So what you want to know is you want to know when will h of t be 0. So this gives you the number of feet where t is in seconds. Okay, so this tells you how high it is above the ground in feet when t is in seconds. And so I want to know when will -16t squared plus 32t plus 48 equal 0. So that's what we're after. And so now we've got a couple options. We can either use a quadratic formula or we can try to factor it. And before we do either of those, notice that I can take both of the sides of this equation and divide by 16. Or multiply by -1/16. As long as you do the same thing on both sides, you haven't changed anything. If you do that, you're going to get t squared minus 2t minus 3 is equal to 0. Holy smokes, does that ever look a lot nicer? See that? So that's the advantage of just knowing some of your multiplication tables and realizing that these are all products, these are all multiples of 16 here. Okay? So that's why it's kind of nice just to be familiar with numbers enough to realize that. Now, I could use a quadratic formula on that, but I think it's also easy just to factor it. I think this factors into what? T minus 3 times t plus 1 is equal to 0. Do you agree? Because notice that this gives you t squared. You're going to get minus 3t plus t is minus 2t, and then minus 3. So 0 is your friend. You know that either t minus 3 has got to be 0 or t plus 1's got to be 0. This tells you that t's got to be 3. This tells you that t's got to be -1. -1. Well, unless you're in science fiction, it doesn't make sense to have a negative time. So must be that the only time possible then is the positive time. I just erased it. So at time equal to 3, that thing is going to hit the ground. See that? And just to show you, if you would have used the quadratic formula on that, which I keep erasing, let's go ahead and do it. This is a 1 right there. So we're going to get what? X is equal to minus b. So minus a -2. If you minus a -2, you're going to have a +2. Plus or minus the square root of b squared. So I take a -2 and square it. -2 squared is 4. Minus 4 times a times c. 4 times this times this. So 4 times 1 is 4. And then 4 times negative 3 is going to be a plus 12. Plus 12. All over 2 times 1 is 2. So that's 2 plus or minus. This is the square root of 16. What's the square root of 16? Do you agree that that's 4 over 2? So 2 plus 4 is 6. 6 divided by 2 is 3. 2 minus 4 is negative 2. Negative 2 over 2 is negative 1. See that? You get the same answers there as you did there. And if you would have done it with this, you could have done it with that as well. You'd have just had a whole lot bigger numbers to work with. Okay, very good. So there's the quadratic equation and the quadratic formula that gives you the solution to it. See you next time.